Hello guys, welcome back to Math Zone African Motives. Still working on our mathematics N6. This is the integration of partial fractions. Working with the question paper of August 2021. So we want to check how we were supposed to attempt these typical questions on our integration using our partial fractions. All right, so as we know that the application of our partial fractions is a continuation from our N5, and what we are supposed to do is to make sure that we express each and every part that we are given as partial fractions in the simplest form before performing any integration, that you are given. All right, so this is what we have on question number 3. So I'm going to take this part. This is 3.1. We are given to integrate x plus 3 in a bracket into x minus 4 like this over, this is 2x cubed minus x squared minus 6x like this with respect to x. So in some of the questions, you see that it's like a repetition of some of the questions that we have done or that you've actually done from another question. It's like that. It's like you just have to know the basics because most of the questions, it will be like a repetition. All right. If we check, we say the first thing, if we are to compare, is the numerator. Do we have a condition that of a proper fraction? Is it a proper fraction? If we expand two brackets, an x here multiplied to an x, it is going to give us x squared. So that means we have got x squared as the highest exponent from the numerator. In the denominator here, the highest exponent is a 3. So it means it's a proper fraction. Remember, a proper fraction is the one that he has got what? The lesser exponent in the numerator compared to the what? To the denominator in terms of what? The functions that you are given. So it means this is a proper fraction. It's a proper fraction. So let us simplify and see what you're going to have. Can we factorize the denominator? All right, let us work with our partial fraction first, x plus 3. So there's no need for even you to expand. If you want, you can expand the numerator, but there's no need here. But the denominator, we can see that x is somewhat common, but x here, but x here. So we can factor out this x. So we are going to remain with 2x squared divided by x, which 2x cubed, sorry, divided by x, which is going to be 2x squared minus x squared divided to this x. This is going to be minus x. Minus 6x divided to this x, it is going to give us a minus 6x, and x is going to cancel. So as we can see here, we've got a linear expression. And on this part here, we have got a quadratic expression. But of this quadratic, we are supposed to check, right? On this quadratic, we are supposed to check first, is it possible for us to factorize this? Can this quadratic expression be factorized? This 2x squared minus x minus 6. So we are back to that factorization that we used to talk about in our N3, N2, right? 2x squared minus 6 minus x minus 6. We're going to multiply the first term, the last term, since the coefficient of x squared in this case is not 1. So you multiply first and last term, we get what? Negative 12x squared. So do we have factors of negative 12x squared? We need factors of negative 12x squared. But these factors or the products of negative 12x squared should give us negative 1. So we think of two numbers that you multiply to get negative 12. Think of negative 4 and 3. If we multiply these two numbers, we get a negative 12. If we add these two numbers, we get negative 1. So just going to put x and x here. So by grouping, we are going to substitute these two terms into the middle term where we have what? Minus x. So that means this is going to give us 2x squared. We substitute the two terms, minus 4x plus 3x minus 6 like this. So that we can apply by grouping into two terms. We're going to factor out 2x. That will be 2x squared divided by 2x, which is x minus 2 in this case. This case, we're going to divide 3. We can factor out 3. That is going to give us what? X minus 2, all right, if we divide properly. Since the two brackets are the same, guys, we know the concept. We are going to take or to factor out that common bracket, and you remain here with 2x on this part. It's going to be 2x, and this will be a plus 3. So we are going to remain with 2x plus 3. Okay. So meaning to say, this quadratic expression can be factorized further, right? Can be factorized further, and it is going to give us what? It is going to give us from the quadratic expression, this was going to be x plus 3 into the bracket of x minus 4. All right, so this is x minus 4 over, remember already there was an x which was outside. So we have that x. Then the quadratic expression, this one factorized, it is giving us 2 brackets. So I don't know the method that you're going to use to factorize that quadratic, but you're going to have 2 brackets, the one of x minus 2 and 2x plus 3. So these are the 2 brackets that you're going to have, 2x plus 3. All right, this one is going to be an interesting question. It's just going to be an easier question. We can see that all of these factors that we have in the denominator are linear expressions. So this is like back to our N5, the linear, a linear, a linear. So this one, it was an exact question like what we had in N5. Remember, how do you expand linear? So it's a over x. So that will be a over x plus b over x minus 2. So this is b over x minus 2 plus c over 2x minus 2x plus 3. So like I said, these are linear expressions, all of these. So that's it. We can equate the numerators considering the numerator from the left-hand side, what we have in the numerator, in this case from the left-hand side. This is the whole part that we have here as it is. So we have got 2 brackets there, x plus 3 into x plus 4. So this is x plus 3 into the bracket of x minus 4. All right, so that's x minus 4. All right. Then we move on to the right-hand side now. So this is equal to the right-hand side. We've got a as the numerator. So we've got a into, I said that you divide to the LCD. This represents the whole of these brackets, everything everything that we have on the right-hand side here, everything here is contained in this denominator. So that acts as your LCD. Remember, these were taken from here. So it's your LCD. So you divide back the x and the x will cancel, meaning to say you remain with these 2 brackets, all right? So we are going to remain with 2 brackets, the bracket of x minus 2 and the bracket of 2x plus 3. So this is what we have, and the bracket of 2x plus 3. Okay. We move on to the other part, which is plus b. So this is going to be plus b. We do the same thing. The bracket of x minus 1, x minus 2, and this one, we remain with x and 2x plus 3. So you're going to remain there with the x, all right? So this is just going to be x here into 2x plus 3, as we saw that x minus 2 and x minus 2 cancel, so you remain with 2x plus 3. So this will be 2x plus 3. All right, plus we do the same thing, the 2x plus 3 here, and the 2x plus 3 was going to cancel. You remain with x and x minus 2, all right? So it's going to be cx into x minus 2. All right, this one and this one canceled. So that is the whole idea there. So now we have to determine the value of a, b, and c from this. It's now up to you. How can you have the value of a, b, and c? By equating the linear terms, the linear brackets or linear terms to 0. We have got x minus 2 here. We're going to equate this to 0. So let us just say, let this x minus 2 be equal to 0. So if we let this x minus 2 to be equal to 0, it means x is equal to 2. At that moment, transpose 2 to the other side, negative 2, it becomes what? A positive. But what it means is that wherever there's an x minus 2, wherever there's an x minus 2, it's now a 0 there. Wherever we see x minus, it's now a 0. So the whole of this part is now a 0. The same thing, the whole of this part will be a 0 because there's what? There's x minus 2. So the bracket of x minus 2 gives you a 0. That is the idea. But the other part, we have to substitute what? What are we substituting? X, which is 2, because we say this is equal to 0. So x is equal to 2. So you're going to substitute a 2 here. We substitute a 2 there. So there's no need for you to expand the brackets. No, just substitute as it is on your calculator. So there are 2 brackets there. So it means we have put something of this nature. X, which is 2. So it's going to be bracket 2 plus 3. All right. Sorry for that. 2 plus 3. So you need 2 plus 3. Close the bracket times x, which is 2. So it's 2 minus 4. So that's 2 minus 4 like this, which is going to give us what? Minus 10. So that means we have got negative 10 from the left-hand side. So negative 10 is equal to, this is now a 0 because there's x minus 2 there, which is what? A 0. This one, a 0 again. So we're going to substitute x on this part. Where there's x, we substitute 2. Here, where there's x, we substitute 2. And here we substitute 2. So it is going to be like this. We have got 2 into the bracket of 2x. So this is 2x, which is 2 times what? 2 times 2 plus 3. All right, so this is going to give us what? 14. So we're going to have 14 times this b, which is outside. So that will be 14b. So we are going to be left with 14b. So the rest, it is 0. The rest is 0 there. So we can find the value of b by dividing both sides by 14. Both sides, so it's negative 10 divided by 14. Negative 10 divided by the answer that we had. That will be negative 5 over 7. Negative 5 over 7. So this is the value of b that we are going to obtain in this case, which is what? Which is negative 5 over 7. All right, let's move on to another part. All right, let's move on to another part. In this case, we were working with the bracket of x minus 2. All right, so we have to choose another bracket again. A linear, as long as it's a linear bracket, there is this part 2x plus 3, 2x plus 3. So if we let the bracket of 2x plus 3 to be equal to 0, it means we have eliminated everything here. We have eliminated everything. But what is going to be the value of x there so that we can substitute here and also here? So what is the value of x? Transpose 3 to the other side, it becomes a negative. Then we divide by 2 because this is 2x. So x is going to be minus 3 over 2. So this is the value of x that we need to substitute on the left to the left-hand side. All right. So in place of x, all right. So you're going to substitute in place of x here. That's a bracket. So you're going to have x minus 3 over 2. So that's minus 3 over 2 like this, plus 3 like this, all right, times the bracket of x minus 4. Our x is minus 3 over 2. So it's minus 3 over a 2 like this. Then we're going to subtract a 4. So that's minus, that's a minus 4 like this. All right, so this is going to give us negative 33 over 34. So that's negative 33 over 34. All right, negative 33 over 4 must be equal to, we substituted to the left-hand side. So we do the same thing on the right-hand side, but there's no need for you to substitute on 2x plus 3 because that's where we said it must be equal to 0. So it's already a 0. The whole of this part is now eliminated. The whole of this part is now eliminated. So you focus where you do not have 2x plus 3 here. So you're going to substitute in place of x. We are going to substitute what? Minus 3 over 2. Remember, our x is minus 3 over 2. So this is x, which is minus 3 over 2 like this, into the bracket of x, which minus 2. So our x is minus 3 over 2. So that's minus 3 over 2. Then we subtract 2, minus 2 like this. So this is going to give us 21 over 4. All right. 21 over 4. So we substitute this part here is giving us 21. The whole of this part is one that is giving us what? 21 over 4. So remember that there is what? A C there. So it's going to be 21 over 4 C. All right. So we got 21 over 4 there, C. So in order for us to obtain C, what are we going to do? We are going to divide this here to 21 over 4. So it's going to be minus 33 over 4 divided by 21 over 4. So it's minus 33 over 4. This one minus 33 over 4 like this, divided to the answer that we got, which is 21 over 4 in the previous case. It's going to be minus 11 over 7. So that's minus 11 over 7. All right, like this. Okay, minus 11 over 7. This is the value of C. Okay, then we need also A. So what can we do this time? All right, what can we do this time to find A? Remember, we worked with the brackets. We worked with the bracket of x minus 2. We worked with the bracket of 2x plus 3. Those are the linear brackets that we have. But if we check properly also, there is a linear term which is not part of a bracket, but it's a linear term, this x here. It's a linear term. Since it is a linear term, we can let that to be equal to 0. So you can even let that x to be equal to what? To be equal to 0. So it means here we have got a 0, here we have got a 0. So the whole of this part is multiplied by a 0 is now as the whole of this part is now multiplied by a 0. So it's going to be a 0. So we are going to substitute x is equal to 0 on the left-hand side where there is x here. We're going to substitute what? A 0. All right. Do we need a calculator here, guys? All right, no problem. Let us just save it, but there we can even do it by side. That's 0 minus what? 0. Remember, you're substituting x, which is 0, so it's 0 plus 3, which is a 3, times 0 minus 4, which is a minus 4. So that will be a negative 12. So this one is going to give us negative 12. So from the left-hand side, we are going to get a negative 12 if we substitute x being what? X being a 0. You do the same thing on this part. We do not have x out of the brackets. So there we are going to substitute properly. Here, there's no need to, don't waste your time because x is 0. So the whole of this part is a 0. All right. So here you're going to substitute a 0 here and a 0 here. So that will be this one, guys, we can do it direct. There's no need for us to even use it. Yes, if you want to calculate and do it. But here it's going to be 0 minus 2, which is minus 2 times 0 plus 3, which is 3. So minus 2 times 3, that's minus 6. So it is going to be minus 6 times what? Minus 6 times A. So to find the value of A, we are going to divide by what? Negative 6. Negative 6, negative 6. So our A is going to be equal to a positive 2. All right. So our A is a 2. We have a B, we have got a C, and this is what we have from our partial fraction here. It's A over X. We're going to substitute whatever that we are given here so that we'll be able to integrate this with respect to X. All right. So this was going to give us what from this formula that we have. We said this is going to give us A over X. Our A, that's 2. So that will be 2 over X. All right. Let me just write a little bit down here. So that is going to be 2 over X. All right. Then the next part is plus B over X minus 2. So B is a negative. So this was going to be plus B negative 5 over 7 like this over X minus 2. This is what you're supposed to have from your partial fraction. Plus C, our C, which is a negative 11 over 7. So that's negative 11 over 7 over 2x plus 2x plus 3, like that. So this is what you're supposed to have after substituting where there's A, B, and C. But remember, this is a question on integration. So the whole of this part that you have substituted, you are supposed to integrate this now with respect to X. That was our question. So you're supposed to integrate this whole thing that we have here with respect to X. It is now representing what we had here previously, the integral that we had here previously, this one. We just changed this into a simpler form that can be integrated. So now that we are at this stage, we have to bring back our integration sign so that we'll be able to integrate. All right, so let us integrate, but before that, we can simplify this so that we can be able to integrate properly. Take the 2 out of the integral. So it's going to be, if we take 2, we are going to remain with the integral of 1 over x. If we remove these 2, that is going to be 1 over x. We integrate this with respect to x. So since this is a sum, so you can integrate each part separately. Remember our n5, we can integrate this separated, okay? So we take also minus 5 over 7 to a plus, it is going to give us what? A negative. So that will be minus 5 over 7. The integral of what? If we remove this here, we remain with what? A 1. So it is going to be 1 over x minus 2 with respect to what? With respect to x. The same thing, a plus and a minus gives us what? A minus. It's going to be minus 11 over 7. If we remove this, take out of the integral, you remain with what? A 1. So that will be 1 over 2x plus 3 with respect to x. So that's where we are, where we can now integrate. At this stage, it's a simpler part because we're supposed to integrate now. So remember the integral of 1 over x is a ln. So this will be ln of x minus 5 over 7. We integrate 1 over this x minus 2. So it's going to be ln again, ln x minus 2 because it's a linear. So you're supposed to find the derivative of this, right, from our ax. But this one, we do not have, like the derivative is a 1. So it does not affect anything. So just leave it like that, ln x minus 2. Then here, okay, I want you to see on this one. This is what I'm trying to say on this part here. If you check properly here, on this integral that we are seeing here, there is a 2x plus 3, which is a linear just like this part. So we're supposed to have our integral as minus 11 over 7 like this. When you integrate this, it was supposed to give you ln 2x plus 3 like this. You find the derivative of this ax, this one. The derivative of ax is what? It's 2. So you divide by 2. So it was actually from this part here. Let me explain it this way. It's gonna take us a lot of time, but that is the idea there. Okay, you integrate this by introducing a ln, then you also differentiate this, so it's gonna be over a 2 from ax. So that is what I was explaining to say. This is x, so it gives you a 1, does not affect. All right, plus the constant of integration. So that is what we are going to have here. So as you can see, we're gonna have 2 ln of x minus 5 over 7, the ln of x minus 2. Then we can multiply. This is, you can even multiply this as 7 times, this is 1 over 2. So it's negative 11 times 1 over 2, which is negative 11 over 7 times 2 is what? 14. So that's negative 11 over 14 ln of 2x plus 3. So just like this part, we put ln of x minus what? X minus 2 plus the constant of integration. So that is how we were supposed to have our integral at the end. So what is important is that as long all these terms are on your final answer, it can be of different order. You can have this here because it depends on how you expanded on these brackets. Maybe you started with the bracket of 2x plus 3 and ended the bracket of x minus 2. The order does not matter. Are you having these terms? Are you having these 3 terms on your final answer with the constant of integration? Are you having them? If they are there with the signs as they are, then your answer is very, very correct. All right. So that is how we're supposed to work out this integral. As we can see, it's a straightforward question that just need us to work with more questions as much as we can. Let's check the other part. Again, it's a partial fraction, and this is given as, that will be the integral of 3x squared. All right, so that's 3.2. So this is 3.2. So this is the integral of 3x squared plus 16x plus 36. So this is plus 16x plus 36 like this. Everything over the 2 brackets, x minus 2 into x squared plus 3x plus 4. Okay, this is what we have with respect to x. Okay, all right. So the question is, can we be able to express this in a simpler form? Let us take our part, this one, and see. This x squared plus 3x plus 4. Can this be factorized? Okay. Do we have factors of 4? Because this is 1. So we need factors of 4 that add up to a 3. Do we have factors of 4 that will add up to a 3? Like two numbers that you can multiply, two numbers that must multiply. These numbers should multiply themselves. But if you multiply them, they are supposed to give you these 3. We do not have, guys. 4, factors of 4. We have just have 2 and 2, 4 and 1, minus 2 and minus 2, minus 4 and minus 1. So there's no way we can add any one of these and get a 3, because we do not have. Remember, we must multiply first. If you multiply these numbers, you must get what? A 4. First, if you multiply those, you must get a 4. Then if you add, you must get a 3. So meaning to say this here cannot be factorized. So it's a quadratic expression that cannot be factorized. And we know how to deal with that quadratic expression that cannot be factorized. I said for that condition, you are going to always expand in the form of ax plus b, like this, over that quadratic expression of ax squared plus bx plus c. All right, we have this in our formula sheet. Let me also show you from the formula sheet so that you move on together. If you check here from our formula sheet, we have, all right, where is my formula sheet, guys? I need my formula sheet here. I want us to check something. I removed it, maybe. Guys, let me try to insert this one. All right, this one. Let me try to insert this page. I want you to see something here, guys. I want you to see something. Okay, very sorry for this. I thought I already have inserted this. But anyways, let me just try and explain to understand here. So on this part, this is your this is the part of the quadratic here, which is given in this format, this one. When f of x is given over ax squared plus bx, when they write it like, it means this one cannot be factorized. So it must give you ax plus f. In this case, like I said, it can be ax plus b. This one becomes c, this one becomes d, and so on. All right? So according to what you're given on your formula, what is important is that it's a times x, all right? Then we add another constant over that same quadratic expression, which cannot, this one, it means when they write it like, it means it cannot be factorized. These are the ones which are factorized, these ones. If it is written like ax plus, it can be factorized, it's already factorized. But this one, once it's written like this, it means it cannot be factorized, such as maybe x squared plus 1 or x squared plus 4. It cannot be factorized. Like this one, we saw that it cannot be factorized. So it means we are going to expand it that way. All right. So this here, we are going to let 3x squared plus 16x plus 26 plus 16x plus 26 in this case over x minus 2 into the bracket of x squared plus 3x plus 4 to be equal to. All right, so the first part is a linear. So as for a linear, we do not have any hassle there. It's just a over x minus 2. So this is a over x minus 2. Then this quadratic that cannot be factorized, so it is going to be plus bx plus another constant. So it's going to be bx plus c. Take note. We have already used the a, so it's no longer possible for us to write ax plus b. We are continuing from a, we move on to b, so it's going to be bx plus c. All right, over that quadratic x, that cannot be factorized, so it remains as it is, over x squared plus 3x plus 4. It cannot be factorized. There's nothing that you're going to do. That's how you expand it. All right, I hope we are together on this part. Now that we've got this, we are back now finding of a, b, and c. So just going to equate our numerators. So we've got the numerator of the first part, 3x squared plus 16x plus 26. In this case, this is the numerator, is equal to here. We have got a, so that is going to be a into the x minus 2 and the x minus 2, just like I explained before, you cancel. So you remain with the bracket of x squared plus 3x plus a 4, like this. All right. We do the same thing plus the numerator here, which is bx plus c. So bx plus c is our numerator. Though it's an expression, just open a bracket. So the x squared plus 3x plus 4 and this x squared plus, they cancel each other. So you remain with a bracket of what? X minus 2. So there we are going to have another bracket of x minus 2. So that's it. There is nothing that we are going to get from this quadratic. We failed to factorize it in the first place. So how do we expect to get solutions from there? So there's no way we can let that to be equal to 0. There's nothing that we're going to get. So we work with the linear expression. Do we have a linear part that we can let it to be equal to 0? Yes, we have. If we check here on x minus 2, it's a linear expression. The highest exponent there is a 1. Yes, this one is a linear, but it has got 2 unknown values, so there's nothing that we can do. So we take the bracket of x minus 2. We let that to be equal to 0. So if we let the bracket of x minus 2 to be equal to 0, which is a linear expression, it means x will be equal to, transpose this, it will be a positive 2. So at a condition where x minus 2 is equal to 0, at that moment, x must be equal to 2. So that 2 minus 2 gives us what? Gives us a 0. So it means we're going to substitute x is equal to 2 on the other part. On the left-hand side, wherever there's x, I'm going to substitute what? A 2. All right. So let us substitute and see what we are going to obtain from the left-hand side. All right. Let us do this calculator. So we've got 3x squared. So this is 3 into x, which is 2. So it's going to be x squared like this, plus 16x, which is 16 times 2. So you open a bracket, 16 times 2 plus what? Plus 26 like this. So this is going to give us a 70. All right. So 70 from the left-hand side is equal to, where there's x on this part of the quadratic, we're going to substitute again a 2. So that will be like this, 2 squared. So this is 2 squared plus 2 times 3 times 2, that's 3 times 2 like this, plus 4. Wherever there's x, we substitute what? A 2. Where there's x, put a 2. Where there's x, we put a 2. So this is going to give us 14. But there's an a there, so it's going to be 14a. So we have substituted x, which is 2 here, x, which is 2. But here there's no need because this is a single term. So once this gives you a 0, it means it multiplies everything. It's now a what? It's now a 0. So don't waste your time substituting there. So to find a, you're going to divide 70 divided by 14. So that's 70 divided by the answer that we got, which is what? Which is a 5. So a in this case was going to give us a 5. So to find B, to find C, it's impossible for us to have another bracket, all right? It's impossible for us to have another bracket that we are going to equate to 0 because this is a quadratic and we can't find anything. Also here, there's nothing that you're going to do. So I said, when you are done, when you are limited to say you can't equate anything, you can't like equate any bracket to 0. You expand the brackets and equate the coefficients of equivalent terms. So you expand everything that you are given. So by expanding here, we are going to see that from the left-hand side, this is going to remain, is already in an expanded form. So this is going to be 3x squared plus 16x plus 26 like this, which is equal to, let us expand what we have on the right-hand side here. We're going to expand by a. So a is multiplying everything. That will be a x squared, a times 3 here, which is going to be 3 ax. All right. Then a times 4 here, which is going to be plus 4a. So this is plus 4a. All right. Then on the other side, we're expanding by bx. So it's going to be bx times x here, which is going to give us what? Bx squared. All right, x and x, that will be x squared. Then bx and minus 2 here, which is going to be minus 2bx. So this will be minus 2bx, okay? We move on to the other term by c times x, that will be cx. Then c times -2, which is minus 2c. So this is what you're supposed to have done. By expanding, we can equate the coefficients of corresponding terms that are correspond to each other. So we can think of the x squared, all right, the coefficient of x squared in this case from the left-hand side of our equation. The coefficient of x squared, we have got a 3. So 3 is equal to, on the right-hand side here, do we have any part with x squared? Yes, there is x squared on this side here. There is x squared here. What is the coefficient there? That is a. So this is going to be a. Also, there's another x squared. What is the coefficient there? That's a plus b. So we're going to have a plus b, which is equal to 3. Do we have any of these values, a or b? Yes, we have a here. We calculated a before. So we are just going to substitute because we have this a. All right, we calculated a before. So 5 plus b is supposed to be equal to 3. So transpose 3 minus 5 is going to be what? Minus 2 is equal to b. So that's our b is going to be a -2. So we have a, which is true. We have b, which is true, but we are limited still because we do not have what? We do not have c. We are left with c in this case. So with this, how can we find the value of c? All right, just like what we did on x, we on this b, we are going to do the same thing. All right, I want to indicate this and also indicate this. Okay, so just like what we did on finding of b, equating the coefficients, we worked with the coefficients of what? Of x squared. What is on x squared here is supposed to be equal to the x squared on the right side. So it is the same thing even on x, even on the constant. So if we work with the coefficient of x in this case, it follows that the coefficient of x on the left-hand side, which is 16 in this case, must be equal to everything as long it is a coefficient of x on the right-hand side. So here we have 3ax, there we've got x. So the coefficient there is what? Is 3a. So this is going to be 3a. We have another x here, so we've got an x here, which is minus 2b. We take the coefficient there, that's minus 2b. Then cx, we've got x here. What is the coefficient there? The coefficient is a c. So that is where we have x. We equate only where there is x, not where there's, this one is a constant, there is no x there. Only where there is x. So if you can do this, you can substitute because we can substitute because we have the value of a, you have the value of b. Remember, a is 5. So in place of a here, we are going to put a 5. And our b is -2. In place of b, we are going to put a -2. So that is how we play around with this question. All right, so this one, guys, is just you and your calculator. You can simplify what is here on the right-hand side. So it's 3 times what? X, 3 times a, remember, it's 5. So it's 3 times 5 minus 2 times what? Minus 2 times minus 2, like this. So this is going to give us 19. All right, so it means we've got a 19. So C, 16 is equal to 19 plus C. Transpose this 19 becomes a negative. So 16 minus 19, that's minus 3 is equal to C. So C is what? Our C in this case, sorry, is going to be a -3. It's one and the same thing as minus 3 is equal to C. So this is what we have. We have the value of A. We have the value of B. We have the value of C. After everything, we can now go back and substitute into our bypass, into our partial fraction part. A over x, this is what you're supposed to have. From all that we had before, it is supposed to be written this way. A over x minus what? A over x minus 2. So let's do that and see. We've got the value of A, which is what? 5. So it's 5 over x minus 2. That is what we have. The A over, so this whole integral, this whole part is going to be A, which is 5. We said 5 over x minus 2. That is what we were given here, A over x minus 2. All right, so you're going to have plus bx. All right, so this is what you're going to do so that you do not have a confusion. Plus bx. Here it's bx plus c. Our b is -2. So it's -2x, bx, -2x plus c, our c, which is -3, like this. So this is what we have here, where they are saying bx plus c over that quadratic expression, x squared plus 3x plus 4. So this whole thing is over x squared plus 3x plus 4, like this. So this is what you are supposed to actually have after substituting your a, your b, and your c. But this is supposed to be what? Integrated with respect to x. So that's it. We can have our fractions separated. Remember, I talked about a condition. This is a term, and this is also a term over a single denominator like that. We can separate these two terms, -2 and this -3 that you are given. A plus b over c. Remember, it is equal to a over c plus b over c. Do not forget that. So you can separate. You can separate your fractions. That's what I'm trying to say here. All right. I want to remove this first. So you can separate your fractions. So meaning to say, this was going to give us, take the 5 out of the integral. So it's going to be 5. We remain with a 1 if we remove this. So that will be 1 over x minus 2. 1 over x minus 2 with respect to x. All right. A plus and a minus here. That's a minus. It's going to be minus. All right. The integral of, we're going to leave, you can leave the 2x as it is on top, or we can take that 2x down. All right, in fact, here, let me check. 2x, instead of separating, guys, we can even integrate this. All right, there's no need. Let us just factor out this negative here. If I factor out the negative, this will be positive. 2x, positive 3. All right, everything over x squared plus 3x plus 4, like this. Remember, integration is not like something that is direct that you can say, no, yeah, I can use this. No. If you check properly, yes, we could have separated that part. But if you check, there's something happening here. This is 2x plus 3. There's a possibility of having 2x plus 3 there. So meaning to say here, we can use substitution method. So we are going to use substitution method here. We can apply substitution. Here it's direct, all right? So let us integrate the first part. So the first part, you're going to integrate 5. Remember at this part, guys, we talked about this. So this will be a ln. So it will be ln x minus 2. And the derivative here is a 1. So it's not going to affect anything. All right, minus. Okay. Like I said, here we can use substitution method by letting u to be equal to the quadratic that we are given here. We are going to see this. If we let our u to be the quadratic in the denominator, this will be u is equal to x squared plus 3x plus f4. Remember, you have to find the derivative of u with respect to x, which is 2x plus 3. Then we find or make dx the subject. So this is same as over 1. So if you find dx as the subject, it's going to be du over this bracket, over this expression of 2x plus 3, which is exactly what we have on this part, 2x plus 3. So what it means in our normal integral, it was going to be like this. It was going to be the integral of the 2x plus 3 that we see, 2x plus 3 over this whole part, which you said is now a u. So it is now a u like this times dx. What is representing dx is du over 2x plus 3. So this is 2x plus 3. So this and this was going to cancel. Are we together there, guys? Substitution. And these ones we can even, by just inspecting you, there is no need for even you to do like this, but for the sake of all of us understanding. All right. So that will be this one and this one cancels, get a 1. So we are left with 1 over u. The integral of 1 over u, like with respect to u, what is the integral of 1 over u? It's a ln u. Just like the previous case where we had got a 1 over x minus 2 gave us a ln. So this one is a straight ln that we are given. There's no other terms, just ln u. But we have the u here, which is x squared plus 3, the one that we are given. So this was going to ln of x squared plus 3x plus f4. This is what you're supposed to have. All right. So by substitution method, this is what you're supposed to have on this integral here. So the answer was going to be minus what we got on that answer. Remember, we got here after integrating everything, we got the ln. So it was going to be minus the ln open bracket. So this is the ln of this quadratic expression as it is, x squared plus this and that as it is, which is x squared plus 3x plus 4 as it is, that bracket as it was before, plus the constant of integration. We are done. So that is how we're supposed to integrate this. So we see, guys, we see it's a learn a lot stage of N6. It's a learn a lot stage. That is why it's called the final level of our N-method. It's a learn a lot from everything that we did since N1. They want you to recall everything from N1. They want you to recall everything. You must recall laws of exponents, this and that, expansion of brackets from our N1, because they want you to know those so that you can be able to answer this. It's not like you are going to be given a certain person, use substitution method. But you see, later on, we are using substitution method. But this is something else. You see, it's like dealing with partial fraction, but there we are having substitution. It's another part that we did in N5 as a topic. It was as a topic in N5. So that's why I'm saying it's a learn a lot. You have to also know your basics of N5, all right? Our N5 here, substitution method. So make sure that you also revise your algebraic substitution. We talked about this as an introduction at N5. So make sure that you revise as much persons so that you'll be able to pass your exams.